Oh, hi, friends. Hello. This is a server. Yes, it's a server. You see, you can pop disks out and all kinds of things. Um, but today we're not going to talk about servers. We're going to talk about serverless. I was supposed to throw this away, but I don't want to. I don't want to damage it. So, hello, friends, and welcome to the AWS Builder Center trivia stream thing. My name is Darko, and today I'm going to be here with you on live, on chat, on Twitch, where's it? Twitch, YouTube, and Facebook. And we're going to be talking about serverless. What is serverless? How do you use it? How do you develop with it? Some of its caveats, some of its pitfalls. And I'm going to be asking you a couple of questions around serverless and to see how much do you know. So without further ado, to introduce myself, my name is Darko. I'm what they call these days a developer advocate. That means I get to talk to you, friends, about computers, technology, open source, AWS, programming, old computers, and absolutely everything in between. I'm based out of Seattle, Washington. I am originally from Serbia, hence the weird accent. But yeah, today I'm here with you, and we're going to be talking a couple of cool things. I see Erie Edit is here. Hello, 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 everyone. Welcome to the show. So, serverless. Yes, serverless is a term that has been out there for a good old while. It is something that we've been talking in the world of cloud computing for at least, I would say, like 10-ish years, probably slightly longer. And it is a term that has a lot of contention around it, because what exactly is serverless is very much up to debate when it comes to a lot of people. I know we can talk about, so what is serverless? What could be, is an S3 bucket serverless? Is an EC2 instance serverless? Technically, in your opinion, the server doesn't exist. It just runs something out there. However, there is a lot of interesting ways to kind of understand what serverless is. It's not a compute model. It's not even a storage model. It's not a networking model. It is more of an operational model. So what does that mean, Darko? What does operationally serverless thing mean? Well, it means that when you manage your infrastructure, when you manage your resources, when you build stuff on the cloud, in a serverless fashion, you do not necessarily care about care about managing a given server, right? In the olden times, we had servers like one I have here under my desk that would run an operating system, run a tech stack, and run your application on top of it, right? There was a bunch of different elements related to it. You had to purchase a server, you had to rack a server, you had to network a server, you had to install an operating system, you had to patch the operating system, you had to maintain the operating system, you have to install software on it, you have to maintain the software on it, you have to deploy your application on it, you have to maintain your application on it. A very kind of a way less a way less flexible way of doing things. And we used to do that for ages. Like, again, a guy talked to you about serverless in a room full of servers. It's kind of ironic, but yes, we used to do that a lot. And since the shift to serverless, we've kind of started shifting our mindset to focusing exclusively on the business logic rather than a big old hunk of metal, an operating system, and a tech stack on it. So I want to tell you all about serverless, right? By the way, also I want to tell you all about chat. Hey, chat, welcome to the show. I see we have Shaikh, we have Afan, we have Yash, we have Jadis. Welcome to the show. Hello to Georgia, United States. Hey. Like that old school keyboard. Yes, you have to be more specific. Well, actually, no. This, my friends, is not a keyboard. It's an actual computer. It's an Apple IIc. And if I do a thing, you will see stuff run on the screen right now. Well, so the thing about serverless is that it's this, I don't want to call it new. It's been here for a long time. It is a way for us to run and operate applications in the cloud specifically. And it changes a bunch of things, a bunch of ways you do stuff. The way you build, the way you approach things. And I'm going to teach you a couple of those things today, and I'm going to give you a couple of questions to ask you, test your knowledge, I guess. I'm going to have a little prize giveaway today. Let me look at my little notes here. So today, for the folks who are going to be on this show, I'm going to drop a link in the chat. Actually, let me see if I can actually even do that. I'm going to drop a link to my friends in the chat, and they're going to drop a link in the chat. one moment. I'm going to do this. I'm going to ask them to share the link to the Builder Center article, and you're gonna be able to well, first of all, check out the show, but I want you to go there and comment. I want you to go there, drop me a comment, because there is a chance for you to kind of walk away from this live stream not only knowing more, but also get a chance to win some AWS credits. We're gonna give out $200 in AWS credits for all of your serverless needs, and if you do it just right, you can actually use those $200 to run a pretty significant application in the cloud, which is pretty shenanigans. Back in my days, $200 didn't really get you a lot of anything in the terms of hosting and running stuff on the cloud, especially if you have to buy a server. So $200 is going to get you a long way, get you quite a ways there. So and also we're going to be giving out this. So I'm going to ask my folks in the StreamYard studio. Can you folks just pop my screen on the screen right now? That is a keyboard, incredibly zoomed out keyboard. I wish there was a better. There we go. That keyboard. We're also going to be giving out that keyboard as well. It is a Keychron Q1, I believe, or a Q1 or a K1. One of the Keychron keyboards, but it is wonderfully built, huge, wonderful, hefty keyboard, metal keyboard, built in the colors of the Builder Center. So what I need you to do, I need you to go to that article on Builder Center that's currently in chat. I want you to drop a comment. I want you to maybe not now. Drop a comment once we start getting to the questions. I want you to drop me your tips and tricks on building serverless stuff on AWS. And then at the end of the show, well, at the end of the day, we're going to be picking out some winners for the $200 AWS credits and the keyboard. So definitely go check it out. I see people reminiscing at the Apple IIs. Yep, Apple IIs are a thing. I don't know if which depends on which Apple II you were using. That will also tell me a little bit about your age. Was it an Apple IIc, Apple II GS, or an Apple II? So yeah, it is great. It's wonderful. It's also running on a wonderful Zenith Data Systems monitor. So if anybody remembers Zenith, shout out to Zenith. Okay, perfect. Let's move on. Let's talk about a couple of things. So I want to first of all, I want to give you an example of a thing before I kick off anything. So, how does serverless actually fit in this modern paradigm of software development, of application hosting, of operations, all those things? I'm going to show you an application first. So give me a second. Let me full screen this, and I'm going to open up GitHub, and there we go. I'm going to show you a repo. Well, first of all, I'm going to show you an application. Could it? There we go. There it is. Nice. So this application here, it is a URL shortener. It's one of those very typical applications we kind of use these days. First of all, let me just stop you. Control C. There we go. It is one of those applications that are kind of very much a hello world type application that people build these days. It's like if you can build a link shortener, you kind of grasp a lot of the elements of a serverless architecture. This application, this serverless, this URL tracker. So if I put the little, I don't know, let me copy paste the link, and I drop the thing here, click shorten. This whole application, this link shortener, including the creation of the links, including the retrieval of the links, including the analytics that's going to be updated here in a second. If I go reopen up a closed tab. Come on, reopen. There we go. These analytics here. See, number one. These analytics, all of these things are absolutely 100% serverless. And why did I choose to build this link shortener as serverless? I could have easily just taken an EC2 instance, taken a Docker container, run it somewhere, have all of my elements, my Apache, my Nginx, my whatever application framework I wanted to use. Why did I complicate my life to build something that's completely serverless? Hear me out. It costs me nothing, practically nothing, to run this application, right? This entire application is literally just a simple website which is an index HTML file, and a JavaScript file with some JavaScript. That's the only cost I have if nothing is going on, right? If there's nothing happening, that's the only cost I have happening. Everything else are Lambda functions, API gateways, and the bunch. So everything that happens here, from pasting the link inside, clicking this shorten link, to clicking this link is an invocation of a Lambda function somewhere in the cloud. So that means there is no such thing as like a idle resource in this case, unless you're going to call an S3 bucket with a single couple of kilobyte index HTML file sitting in it idle. So how does this application actually work? Well, let me show you some code. I think I can go here, and I can go. There you go. Okay. So I'm going to show a little bit of the code here. I built this application using CDK. CDK, there you go. CDK and AWS Lambda. Now, there's going to be a lot of stuff here that's going to be yelling at me because npm install. Basically, I've used this using infrastructure as code, which is one of the very common patterns you will see when people build serverless applications. So infrastructure as code is going to be number one thing you need to look into and consider when building applications, serverless applications. You can absolutely build them with ClickOps. That's not a problem. However, for the best experience for you, you should definitely approach them with a little bit of infrastructure as code. I see some folks have issues with copying the link. Yeah. I think you should be able to access it. Please do go check it out. Complicated serverless does not compute. I mean, serverless can be complicated once you get into it. But to be honest, if you do it well from the start, you should be perfectly fine. So lib and then KRTK stack. Okay, so I want to show you a couple of things here. I'm going to show you how my application looks through the world of code. And there's only a couple of elements to this application. So number one, I have a certificate. The reason I have a certificate, this is just an SSL certificate because I want to use HTTPS. That's it. I have a hosted zone. This is a Route 53 DNS zone because I want to make sure that I can configure everything in this application, including DNS. I have a bucket. This is the bucket where my index HTML file exists. That's it. It's a simple bucket that just is available to the world. And I have something special here. Another element that's usually not typically seen in your simple applications, simple hello world type serverless applications. I have a Kinesis stream. Now, the Kinesis stream here is the little bit more complicated and potentially a little bit more expensive thing. But a Kinesis stream is a serverless component that basically takes analytics from CloudFront and ingests them. Right? It takes them somewhere. What happens is that analytics go from CloudFront, which is my content distribution network, my CDN, and all the click analytics go inside of the Kinesis stream. Why? Well, this is another pattern of serverless applications. It is event-driven architectures, event-driven applications, whatever you want to call them. But basically, when something happens, something is triggered. There's no timer. There is no manual thing. It's literally when a certain amount of analytics gets accumulated inside of CloudFront, they get shipped over. Well, actually, no. Anytime an analytics event happens in CloudFront, it gets piped into Kinesis. Then, when a certain buffer of analytics is inside of the Kinesis stream, Kinesis triggers a Lambda function. This Lambda function picks up these analytics and does something with it, right? So, no manual things, no timers, no scheduled tasks. It's literally when a certain things happen, another certain thing happens. Because in between them, nothing happens. There's no cause. There's nothing happening here. Amazing, right? So this is the thing that powers basically the number of clicks. I won't go into the details. I'll share the link to my repo as well in the chat so you can look at the code, but I just want to explain this thing. So that's my analytics stream. This is my configuration for the analytics. This is my database. Okay, we haven't talked about serverless databases yet. Serverless databases are here, right? We use them. It's been a very common use case to use something called DynamoDB, right? When building serverless applications. So DynamoDB is this like NoSQL non-relational database that's purely serverless. It's just like out there in the cloud. You deploy it, you write to it, you read from it, done. Amazing. So DynamoDB is one of those more common ways of people of people using a serverless database on AWS. So chat, I want to ask you a question. What other serverless database is there out there on AWS? I want to hear your thoughts. What serverless databases exist out there besides DynamoDB? And whoever gets me the correct answer, I don't know. You know what? Go to my article in the chat. Go to my blog post. Write down 2 or 3 serverless databases on AWS, and let me know. Let me know. I wanna hear that. I see schizophrenic web developer. By the way, hey, it's been a while. Aurora, Amazon Aurora serverless is a thing. Yes, absolutely. That is a serverless database. Akil is saying EBS. EBS is not a database. It is an elastic block storage. It's basically a hard disk that you connect to a server. Good shot. Elastic Beanstalk, not necessarily. No, you can technically run an application. Well, so okay, here, this is a philosophical question. Is Elastic Beanstalk serverless, right? If we look at the operational model, it almost could be considered serverless, but not really. Yeah, Supabase, it's not an AWS product, but Supabase is technically a serverless database. Another example is Neon. Shout outs to folks at Neon. Neon is a great serverless database, not an AWS thing, but it's amazing. There is another serverless database that has been launched this year on AWS, and it has slowly become my favorite database. Definitely DynamoDB. Also, shout outs to South Africa. Hey, Lindane. Hello. Okay. I'll let you think about that, but do definitely drop the information in the Builder Center article in the thing. Amazon TimeStream, that's a good call. Amazon TimeStream is technically serverless. Absolutely. Great on you, LinkedIn user. I wish I knew your name, LinkedIn user. RDS. Well, so RDS is not serverless, weirdly enough, even though it kind of has the similar elements, but it's not serverless because there are certain maintenance periods and stuff that you kind of have to not worry about, but they still exist. So technically RDS is not serverless because also, say it with me, it does not scale down to 0. Okay, so FaunaDB. Yes, I've heard so many good things about Fauna. I want to drop a little link in the chat as well. I'm going to drop a link to this serverless application I've been showing. Well, it's not going to be. It's going to be my friends as well. So this is a link to the serverless application I've been building, the one I've been showing you here. So you can go and check that one out. But back to the thing, DynamoDB, very common element of a serverless database, of a serverless application. And lastly, Lambda functions. Lambda functions are basically serverless compute elements. These are the things that run code in the cloud for you. It is such an amazing thing. Basically, you just tell it, here's my piece of code. Please execute when X happens, right? So that can be triggered by a API gateway. That can be triggered by S3 file upload. That can be triggered by a event bridge thing, right? So give it some code, give it an event trigger, and that's it, and give it some permissions. It's the best thing in the world. These Lambda functions are usually meant to perform single bespoke actions. Like in my case, I have 3 Lambda functions. One Lambda function is creating the links. One Lambda function is getting the links. That means when you click on a short link, it gets you. Sorry, the getting the links is gets me all of the links. And the visit link is the one that when you actually click on the link, converts the short link into the long link. So in this case, 3 Lambda functions performing 3 different tasks. I could have technically gotten there into like this whole single Lambda function monolith or Lambdalith as they call it, but I do love to separate my services out. You knew that, yeah. But Lambda isn't the DB; it's more of a exactly. Well, Aki, we're talking about everything here. We're talking about all the serverless elements. I'm here currently inside of the Lambda functions. Oh yes, one more Lambda function I forgot in my repo is the process analytics Lambda. This is the Lambda function that's attached to the Kinesis stream. That means all of the analytics processing is going through this Lambda. And lastly, a lot of the times when you work with Lambda functions, now this is not mandatory, but for applications such as a link shortener, you have to have some sort of a way to create an API, right? So in this case, Amazon API Gateway is the perfect serverless application that enables your Lambda functions to be basically behind an API. So in this case, I have an API gateway that kind of unifies all of these applications inside of a single API. So really good. And in essence, that is the application. There's not a lot more to it. Now, you can see the code that, here's my CloudFront distribution. But you can see my code if you want to go poke around at it. Lambda functions are written in Rust, but Lambda functions are able to be written in many languages. So from your super popular stuff like Python and JavaScript, but to even like .NET, C++, Rust, Go. I've seen Lambda layers for like stuff like Pascal. So if you want to do that, sure, right? Unconditional scenario saying flat file placed on an S3 is considered kind of serverless. Absolutely, it could be, right? I mean, I'm not saying it isn't, right? This is the whole thing where you talk about how do you handle what is serverless, right? You could use a flat file on an S3 bucket as a data store. You're probably going to run into capacity issues at certain points because to edit that file, you actually have to retrieve the entire file, make the changes, write it back. There is no, check, what's the word, write blocking or whatnot. What if somebody else does it at the same time? So don't do that. It would be highly irresponsible to do that. Okay, speaking of highly irresponsible, I have a question for you. A little trivia thing here. So let's see how this works. So question number 1, folks. It's an easier one. What was the first AWS serverless service? A, put it in the chat. A, B, C, or D. A, Amazon SQS. B, AWS Lambda. C, AWS OpsWorks. Or D, Amazon SimpleDB. If folks out there know what SimpleDB is or what OpsWorks is, shout outs to the OGs. I should have some sort of like Jeopardy music here, like doom, doom, doom. It is quite interesting. One of these services is actually quite special. Not only that it is the first serverless service, but it is also the first service. Yeah. Look at that. Look at the chat. Look at chat. Oh my God. It is like I see where you're coming all from. Yep. You also as SQS and AWS Lambda. Look at that. Yep. Well, actually, my friends, it is up. It's not. It's SQS. It's Amazon SQS. I have to actually look it up. Is it Amazon or AWS SQS? It's Amazon SQS or the Amazon Simple Queue service. Simon is saying E. Absolutely. I will tell me what the E service is. It is Amazon SQS. And again, fun fact: Amazon SQS is the first service that was launched by AWS. It's older than Amazon S3. So the first ever service that was available on AWS is the first service we've created. I think S3 was the first one available, but the first service created is Amazon SQS. It is also a critical element on serverless applications when it comes to decoupling applications. So what is decoupling? Decoupling is a way of creating loose connections between different services in an application. Let me show you. So in my link shortener example, so when somebody clicks on a link, did I break my application? Oh no! Oh, just people are spamming. Oh, great. So I'm not gonna click on those links, by the way, just so you know. And go for it and spam as much as you want. It's serverless. So anytime I click on a specific link here, so like when I click on this link here, this link does not go ahead and call a Lambda function called update analytics and bumps up this number to number 20. Right? It doesn't do that. What it does, it actually goes ahead and just drops the analytics thing. Well, the analytics thing gets dropped into a Kinesis stream, and then down the line, something else picks it up and does it. Why do we do that? Why would you do that? Why would this thing be the case? I want to hear your chat. Saikrishivigat is saying, I expected the answer. Well, the answer, my friend, is Amazon SQS. That is the answer. It's A. It's not Lambda. Yeah, just so you know. So why do we decouple services? Because we do not want services to be 100% reliant on each other, at least not in a very rigid way. For example, what if my analytics service was having capacity issues? What if my analytics service had a problem? Nobody could click on a link before the analytics service was invoked. This means I have created something called graceful degradation. That means if my part of my service doesn't really work, it doesn't matter because a user can still click on this link and get them somewhere to show. So yeah, so that's one of the reasons. And Amazon SQS is one of those services that it's critical here. It's a queuing service. Basically, you drop in a message into the queue and something picks up that message at some time. So incredibly valuable element of a serverless architecture. Okay, let's talk about one more important element of a serverless architecture. So let's talk about deploying and testing. So chat, tell me, what type of testing is there in software development? I would love to hear you. What type of tests exist in software development? I don't have a question for this right now on the screen, but I would love you to hear you. What type of tests exist in the world of software development? That means when you are writing code, when you are deploying code, when your code is going through a CI/CD pipeline, what kind of tests exist? And I see a couple of comments here. Schizophrenic web developer, end-to-end, unit testing, integration testing. Absolutely. We can talk about things such as penetration testing, user acceptance testing. What other things exist? Compliance testing. There's a bunch of different testings you can do. Unit testing is one of the most common ones. But I actually want to talk about something called integration testing. So when it comes to integration testing, A/B testing, great job, Nathan. Integration testing is basically testing a specific element of your service so it's compatible with other elements of your service. In the past, well, not in the past, in non-serverless applications, what you would usually have is you would have a kind of a test environment or like a production environment with some sort of way you can test or send data to it and revert the data to it. Basically, you want to make sure that your code change actually works with the rest of the system, not the unit, not a single function, not a single execution, but like it needs to work with the rest of the system. That means it needs to be able to talk with the DynamoDB table. It needs to be able to talk with the API gateway. It needs to be able to talk with whatever other things you have. Serverless applications change that slightly. There's a certain element in when you have the freedom of serverless applications, certain things change. And I have a question for you. So, when moving from a traditional 3-tier web application, right, your data layer, application layer, and presentation layer, to serverless, which of these CI/CD pipeline changes is the most important to implement? A, replace your Docker builds with zip files. B, add automated integration tests that spin up actual AWS resources. C, switch from blue-green to canary deployments. We haven't talked about deployments yet, but switch from blue-green to canary deployments. Or D, remove all unit tests because Lambda functions are stateless. I want to hear what you think. Drop your answers in the chat, A, B, or C. And I will talk why. I will talk about why is the thing that is correct. So, but give it a good read. And if somebody's willing to explain to this, if somebody wants to explain to the wider audience why the correct answer is the correct answer, you can go into my little blog post in the chat that there's a link and you can describe it to us in the comment. I do love me a good old CI/CD pipeline. Back in the day when I was a young little sysadmin, we had no such things as CI/CD pipelines. We would deploy things by basically copying a zip file somewhere, and that was, to say the least, not fun. So yeah. Okay, I see a couple comments here. A B B D B. Okay, come on. I want to see what you think, folks. Give this a read. It's a significantly important thing. Now, it's not the mandatory thing. Hear me out. Like, you can function without implementing this change. However, for a truly serverless experience, for the best in class things you want to do, having the ability to do exactly this it can make your application way safer, way better, way more integrated. Okay, so the answer is to Nitin, to Parsa, to a few other folks here, schizophrenic web developer. It's B. Add automated integration tests that spin up actual AWS resources. So let's all imagine a CI/CD pipeline. Actually, you know what? I don't have a diagram, but let's find a thing. CI/CD pipeline diagram. I'm sure somebody has a really nice diagram of a thing. I'm going to steal somebody from. Who can I steal it from? Let's see. Okay. Is there a nice? Come on, there must be a nice AWS diagram. I know we used to have these things in the past. I think this is. Okay, this is going to work fine. Whoever it is, shout out to this person for building this one. Okay, so let's talk about the source actions, the actions in a pipeline. So there's the source, build, test, and publish, deploy. Right? Those are the four kind of important stages of a CI/CD pipeline. In the source action is where your code gets committed into a repo. That means AWS code commit, GitLab, GitHub, whatever you want to use. The build stage this is where your application is getting picked up and compiled. Now, your application may not be compilable. You're maybe using Python or JavaScript or whatnot. But this is where usually your unit tests run. This is where the unit testing happens. The next stage, the test stage, this is where the integration tests happen. This is where your application is actually being tested against other things. Now, in a traditional application, a non-serverless application, what you would do is you would basically have your application invoke a test version of your public application that exists somewhere in the cloud, right? You would have an alpha stage or a beta stage or something that's out there existing, and you would kind of invoke it on that one. In a serverless environment, the test stage actually does a bunch of different things. So in the test stage, what would happen here is you would actually go ahead and spin up these resources, right? You have your infrastructure as code, right? We talked about it. In the test stage, that same infrastructure as code with a flag called testing or whatever gets deployed, and your application is actually being tested against the deployed resources. Because it is serverless, it is very quick to deploy. It is relatively cheap, and you destroy it at the end, right? It is such a fantastic thing because you actually get to test out things that are, well, if things are good, right? You will understand if this actually works or not with the rest of your system. It gives you so much more confidence in your application instead of having to have this constantly existing application in the cloud that eats up resources, that sits around idle. Integration tests can now deploy AWS resources that need to be tested against, which is just an amazing little thing. Excellent. Okay, let's move on to what's the time? We're good on time. Let's move on to the next question. Let's do this. That's not it. Presenter slides. Okay. Question number 3. Okay. Service integration question. We're kind of like we're keeping in the terms of integrations, and I've talked about this a moment ago. Well, today, but question: you're building a serverless e-commerce order processing system. A customer places an order through an API gateway to a Lambda function to a DynamoDB table. Now we need to trigger an inventory update, send confirmation emails, and update analytics. What is the best architectural pattern? A, have the original Lambda function call all downstream services directly. B, create a step function workflow to orchestrate all the steps. C, use DynamoDB streams to trigger event bridge, which fans out to multiple Lambda function. Or D, use SQS queues between each of the services. Your time starts, there's no time, but let me know in the chat, what do you think is the correct answer here? I see a couple of people. Schizophrenic web developer C, Jib Jab says C, Murat says C. I want to hear. I want to hear answers here. Look at that. Could be B. Yep, you're absolutely right on conditional surrender. Could be absolutely B. Now, a lot of these things could be the answer. Like I made sure that they're not obviously the answer is not obvious, super obvious, unless it's still a trivia thing, right? So Nathan says C, Parsa says C, Walber says D, Freddie says C, Devang says C. Okay, look, I see my serverless folks. You know their stuff. Pat says B or C. Absolutely. I mean, if this was an AWS training and certification live stream, I would probably be under a lot more scrutiny to write these questions in a lot more specific way. But it's not a training and certification live stream. Shout out to TNC. But it is actually, the answer is C. Using DynamoDB streams to trigger event bridge that will fan out to multiple Lambda functions. So, Chris, yes. Shout outs to TNC. So many of them can be, but C is most efficient. Exactly, Murat, that's correct. C is absolutely the most efficient example here. Let's talk about why other things are not, right? So what's happening here? So you have an e-commerce application. So somebody goes and you go there and buy a server, right? You click that buy button and through a Lambda function goes into, through an API gateway, through a Lambda function, goes into the DynamoDB table. So that means the order, whatever, has been placed inside of a DynamoDB table. This DynamoDB table contains all of the orders. To update a centralized table or a database or whatever that contains all of the inventory, you could do that. Like you could have basically the original Lambda function that creates the order go ahead and update a database somewhere out there to update the inventory. That's been kind of a very common thing that people use, right? It's a very much a pattern that people use. But what's the problem with that pattern, chat? What is the problem with that pattern? Why wouldn't we use this? And I talked about this a second ago. Why wouldn't you use A? While I put my disk caddy back in my server. Why wouldn't you use A? Well, question for BD. I don't know. Did I get all of the? Did I make it like that? I don't think. I'm not gonna say it. Why would I say that? It would be weird if I did. So the reason A is not a good thing is because you're creating a strongly coupled dependency. That means if for some whatever reason you couldn't update the inventory, your user couldn't purchase. You don't want that, right? You want to sell this server. You want the user to be able to click a button, buy stuff, and go on their merry way. If you cannot update the inventory, that's a you problem, right? So creating a coupled system like this doesn't really work. B, creating a step functions workflow to orchestrate all the steps is a good way to do it. Absolutely. Step functions are basically your state machines where you can create these complex workflows to orchestrate multiple different actions. Like this can fan out into different things and do a bunch of stuff. Absolutely, you can. It is a little bit more complex. It's actually potentially, depending on your system, it's potentially overly complex for such a thing. C on the use SQS between each service. Sure, you could do that, but the problem with SQS is what are we trying to do here? We're trying to update so we're trying to update both the purchasing table and the table that contains the inventory. An SQS message can be read only once. That's it, only once. So only a single service can consume a message. That means as soon as the message goes into the queue, something reads it, that's it, right? So SQS queues wouldn't work here because we would kind of run into a problem. So C it is. Basically, DynamoDB streams, when something is written to DynamoDB, it can trigger an event bridge with the data. And when it triggers an event bridge is basically an event bus that can do multiple different things. So a message goes into the event bus that can trigger multiple Lambda functions, multiple different things. Things can react to it in the event-driven architecture. Unconditional server. Yeah, thank you so much, man. I appreciate you for coming here. Murat says, can you compare all those four options in means of billing? Here's the thing. Put my server down since I have to be serious for a second here. So when it comes to costs in serverless, it all depends on scale. You want to control that as much as you can, right? None of these examples here would have any significant impact on cost, right? The only cost element here that would be is basically how much Lambda functions are you calling and how often. So that means is if you choose any of these things, and I mean any, cost would be roughly the same, right? Maybe step function workflows will be slightly more complex. We have to have a state machine running. If you have SQS queues, you may have to send 2 messages at once, right? In essence, the cheapest option with the best user experience would be number C. Well, would be C. A would be very cost effective because you just make an extra call to whatever. However, the user experience is worse. So keep that in mind. So Walter is saying, does A provide transaction capabilities forever in a case of a failed call inside the original Lambda function? Now, by default, no, right? You would have to implement that kind of a thing. You would have to actually verify, has this thing been written around? So this could be potentially down to you, or also down to your database. I mean, your inventory database doesn't have to be DynamoDB. It can be whatever you want. It can be somebody mentioned it can be absolutely a flat file on an S3 bucket. It shouldn't, but it can. So there is no like transaction built into the actual Lambda function itself. So depending on what kind of call you make, depending what you're doing, this is the whole thing. The same goes for C. Like you're still going to have a Lambda function somewhere down the line that's going to write this data to whatever data store you want. So it really depends on where you're writing stuff to. Okay. So I want to show you something here. So let me do a thing. I need to go and log in to a thing. 1 second. I want to show you a little bit of EventBridge. But first, I need to open up my AWS console. And to do that, I need to do a little dance on this side. Give me a second. Looking at a different screen. Chat, while I'm doing this, you should absolutely go to my blog post, and you should absolutely drop a comment or 5 onto that blog post to tell me a little bit about how you handle event-driven architectures, because I do want to hear that. And there's a good chance for you to win $200 in AWS credits and an amazing AWS keyboard, Builder Center keyboard. You can win this, which is great. Pay-per-use will be limited in serverless options. Nathan, basically, I mean, it is pay per use, right? Serverless is the epitome of like pay as you use, right? Anytime. So for example, how are Lambda functions being built? It's basically per invocation and the length of invocation. But in essence, there's no cost for your Lambda function not doing anything. Anytime a user goes ahead and invokes a Lambda function, you're being built. But it's like AWS Lambda pricing. So it's there we go. It costs. It's a kind of a weird thing because there's also a little bit of of gigabytes, but it's like gigabyte seconds per month. So that means you get billed whatever this number is for every gigabyte second, and you get 20 cents per 1 million requests, right? So yeah, maintenance cost of servers will. I mean, there's no maintenance cost of servers, right? There's no servers to maintain, my friend. It's literally just requests. And this application here that people have been spamming quite a lot. Is the spam still happening? It is still happening. Look at that. Somebody has decided to crash. Go for it, my friend. So basically, this thing costs me nothing. Like nothing. I run this, it just costs me nothing. Maybe now because somebody's kind of spamming it, but because basically what's happening right now, a bunch of invocations are happening to my serverless thing, and probably there's going to be a bunch of throttling happening because I did enable throttling. Like you can do more like than certain amount of requests per second. So yeah, but you are able to control your costs even more with serverless. So you have all of those things. Okay, back to the thing. Okay, I want to show you EventBridge. Amazon Event Bridge. What is the time? Okay, so Event Bridge is kind of a way to let me zoom out slightly. There's an event bus. So an event bus is basically a place where certain things happen, right? This is where a message is being sent. So like I have a couple of kind of event listeners rules basically on this event bus, and I can show you how to create a rule, and it will make a lot more sense. So I'm gonna call this Twitch stream. I'm gonna call it Hello Twitch. So anytime an event happens at the bus, right, on the default event bus, there's going to be a specific rule with a pattern, right? And there's a bunch of different patterns, right? Like in this case, for example, let's say, I don't know, let's do DynamoDB, right? Can we do? Let's see, AWS services. What shall we pick? AWS DynamoDB. Where's DynamoDB? DynamoDB. Okay. So basically, AWS API call via CloudTrail. So something happens in there. You know what? No, let's do something simpler. I don't want to do this. Let's do S3. S3, simple storage service, event bucket level API. And like any event happens in this thing, basically it's something's going to be triggered, right? If any S3 event happens, that means any API call is happening, right? Whatever. I can do event notifications, for example. For example, S3 event notifications. I can say a specific event when somebody has, I don't know, object created, when a thing has been created in an S3 bucket, right? And I can do a specific bucket, like I don't know, you know, I would put like something Twitch stream bucket, right? On the specific bucket, when an object is created, a rule in event bus will be triggered. Click next. And then the target. Now, what the target will be here. Now, the target could be literally a Lambda function, right? I can trigger a Lambda function. I will pick a Lambda function here. I don't know, this one. And that's it, right? So what happens right now is somebody uploads a file in the S3 bucket. A Lambda function is triggered. And this specific event on the event bus is passed on to the Lambda function, and that event bus will probably contain things such as the bucket name, the object name, whatever has been actually happened in that API call, and then your Lambda function will invoke like this, and it's great because you have this incredible decoupled control of what's going on. Love it, such a great thing. And this can be anything. There can be many things. Again, I showed you a S3 thing, but it can be some API call that has happened or whatnot. Like it just even supports like CloudTrail. So like if something happens on your account, if somebody creates a bucket or somebody creates a DynamoDB table, that event gets sent over to the event bus, and then something else happens. I don't know. Super flexible. It's just a great way to fine tune and kind of like make your applications very much event driven. So event bus is my favorite database service. If somebody asks me what my favorite service is, it's Event Bridge, Amazon Event Bridge. Okay, last question. Let's go to the last question. Are you ready? Okay, local development and real world considerations. Okay, questions. You're using AWS SAM, serverless application model, for local development of a serverless API. Your function works perfectly locally, but has a 2-second cold start in production. What's the most likely cause that SAM's local testing has missed? A, your Lambda function package is too large. It's bigger than 50 megabytes. B, you're using provision concurrency incorrectly. C, SAM local doesn't simulate VPC networking delays. And D, your function needs more memory allocation. Tell me, what do you think here is? As you're looking at this question, drop your answers in the chat, A, B, C, or D. I want to explain a little bit about SAM, and I think I should have some time to show you a little bit of SAM local. SAM, serverless application model, is an infrastructure as code framework that helps you basically build serverless applications on AWS. It is very nifty. It is really cool. It's just like an amazing service that helps you like kind of simply build applications with all of the bells and whistles you need. It has this feature called SAM Local, which is solves one of the biggest problems in serverless development is being able to test your applications locally. When you develop your applications, like even my example application, when you develop your application, you are basically having to test them by actually deploying them to the cloud, which may not be a problem because the deployments of serverless applications are relatively fast. But if you have a little bit more complex and you want to do something locally, you want to do it on an airplane, I don't know, you can simulate certain AWS elements using SAM local. So you can simulate things such as Lambda functions, you can simulate some things like API gateways, so basically trying your applications out locally. Okay. ABC. Let's look at that. People are commenting. Look at that. I see a lot. The whole spectrum of answers here. Look at that. Do we have a winning thing? Is that even no overwhelming answer? Weirdly enough, do we have an over? We don't have an overwhelming answer. Come on, chat. I want to hear what you think the answer here is. Why would SAM not catch a cold start in production? Shaikh says it's C, I believe. Unconditional Center says maybe C. It absolutely is C, and my answer was not under D. So SAM local doesn't simulate VPC networking delays. That means when you have a SAM function locally, it's just invoked locally. There's no such thing as VPC stuff. Let's talk about VPC networking delays and cold starts. What is a cold start? When a Lambda function needs to be attached to a VPC or a virtual private cloud, basically your network in AWS. When the Lambda function is being executed for the first time after a while, a cold start, it needs to logically attach a network adapter to it, right? Not all Lambda functions exist in a VPC, but if you have a VPC Lambda function, you basically attach a network adapter to the Lambda function. So when you do that, it takes a little bit of time. And that attachment does not happen in a local environment. So it is absolutely one of the things that it would not catch. But this is an important element of your application consideration. When you're building applications, when you're building serverless stuff with Lambda, do not just willy-nilly go ahead and attach them to VPCs unless you need to, right? A lot of times, most of the times, your Lambda functions do not need to be attached to a VPC. So unless you absolutely need to have it in a VPC, don't have it in a VPC. VPCs introduce some certain amount of delays. SAM local will not capture that because SAM local does not really emulate any of those things. And a 2-second cold start can be significant. Absolutely, it can be significant. So please do bear that in mind. I think I can show you one more thing to kind of show you the effects of a cold start. Let me see. I think I can open up this. Let's go to, I have a distributed. Okay, so I have a little. This is another serverless application, but this one is not public yet. It's not public to publish yet. So if I go to a website, I have just index.html here. So I'm going to open index.html, and I want to show you something. So. Okay. Not that. Let me see if I can open up the little inspect window here. Network. Reload. Okay. So when this application runs, there's 2 Lambda functions executing at the same time, right? There's 2 Lambda functions that are running. One gets all of the elements under this drop-down box, and the other one gets all of the elements in a table. This Lambda function currently running under Rust takes 111 milliseconds, right? It's a warm start right now because I reloaded it. It's 111 milliseconds. That's how long it took. I'm going to switch to a different language right now. And this is not the fault of the language. Please bear that in mind. Python is slower, but not that slower. So I'm going to switch to Python. And you're going to see the 2 executions here on the screen that are way slower. So if I switch to Python, look at that, still running, bum, bum, bum. That is, can I even show this? That is 3 seconds. It took 3 seconds for this Lambda function to execute compared to 100 milliseconds in Rust. Again, It's not between Rust and Python in this case. It's because the Rust function was warm and the Python function was cold, right? That's a cold start. If I refresh this again, like that, you will see significantly shorter, 76 milliseconds versus 394 milliseconds, right? Significantly faster. It's not 3 seconds, but it's faster because there's no cold start. That is the big change here. Now, if I go back to Python, see 881. Go back to Rust, 100. See, there you go. They're almost comparable. It's still not the same thing, but it's almost comparable. So understanding the differences in cold starts, understanding these elements in your serverless application is critical. Okay, I wanted to show you a little bit more of local development, but we are getting up there to the thing. So here's what I'll do. The link that has been shared currently by Chris, go ahead and click on that link. Check out my article, drop a like, drop a thing. Please drop a couple of comments in the chat, in the comments there. We're trying to give you $200 in AWS credits and this glorious Keychron keyboard. It's wonderful. I want you to go drop comments there, but also follow me on the AWS Builder Center, because I'm going to be dropping a little blog post about Lambda local development, a little getting started guide with local development, how you can run, test, and build your Lambda applications locally. So because we couldn't cover that right now, I am inviting you to go there and follow my profile and stay tuned for that thing coming in soon. The heart in the keys is pretty. Yes, it is really nice. I love this whole keyword. And also, I'm not sure if you notice. Can I zoom in? I can zoom in. The Y is highlighted. Why is the Y highlighted? If you've ever used Amazon QCLI, you know there's a lot of Ys when you build stuff with this thing. Okay, Simon Herkert is asking, sorry for the late stupid question. It's not a stupid question, but is the event bridge feature because when using AWS services, there's no way to make custom logic sort of easy UI for users, or is it still a library for basic events? It's none of those. It's not even a library. It's basically an event bus, right? So think of it this way. Something happens on AWS, something happens in your application, something happens in S3. You send that event to this bus, right? Imagine this a big old pipe. And on certain events, certain things, when they happen, because of certain rules, that event gets picked up, right? So somebody creates an S3, a file on S3, that event gets sent to the event bridge, and a Lambda function picks it up, right? So that's the main reason for it. Now, these events can come from AWS services, but it can also come from your application. Your Lambda function can write an event inside of an event bridge, and something else can pick it up. So it's a really great way to kind of orchestrate these things. It comes back to like a bus-driven architecture design. So definitely, you should go check out Event Bridge. Super great feature. Couldn't live without it. Okay. I guess that's it for today. I really hope you enjoyed this live stream. My friend Steph and myself will be coming back soon. I think in a couple of weeks, right? On the 22nd, I believe that was the date. We've agreed on the date. We're going to update you. But there's going to be another live stream where we're going to be talking about some developer productivity stuff. So if you're interested in more of these kind of trivia live streams, definitely go check them out. But more importantly, Builder Center, link in the thingy thing. Go check that out. Drop a like, drop a comment on my article, and focus on me, camera. Thank you. And I'll be catching you in the next one. Jeb, I appreciate you, friends, for being here. I thank you. Thank you all for your comments. Thank you all for being part of thank you all for bearing with me for this hour. I'm gonna go ahead now and finally deploy this server. There's no available voucher certification. Can I get? Yeah. Thank you for. Shaik, I can't answer that. Check out the AWS training and certification streams for any sort of certification and voucher questions. Thank you, folks. It's good, Frank. Thank you, friends. Thank you, Takotso. Have a good rest of your day. Bye.